This is the underside of a Linn Sondek LP12. I've had this turntable for about 4 or 5 years now. Bought it off second hand from someone at work. Doesn't get a lot of use, I must say, but I went to use it day before yesterday, and the thing wouldn't start up. Basically, the light came on the switch, the power switch, and but nothing happened. So I thought, oh, okay, the belt's probably fallen off. So I sort of took the outer platter off. Nothing wrong with the belt. Noticed the motor wasn't turning, and so I thought, oh, maybe there's something wrong with the motor, or it's blown a fuse or something. Anyway, I went to give the motor a turn. It was seized up, basically. All the grease is seized up. So I thought, okay, well, I'll give it a bit of a manual twist and got it moving. And sure enough, it started to turn. So it started to work, and it started to play the record. And I thought, that's okay. You know, I'll have to do something about it at some point or other. But when it came to the end of the record, I noticed that the motor was very not buzzing, not electronically noisy, you know, not like a 50 hertz buzz or anything, but it was going, you know, sort of making a dry bearing sound. And I'm thinking, well, if that's the case, I need to get this motor out and have a look at it and probably re-grease it up. So this is the purpose really of this video, but it's also to check the Valhalla upgrade. This is the Valhalla board. The original Linn Sondek worked straight off the mains and was obviously very susceptible to frequency drift and the voltage changes on the line coming in. So I think it was back in, I remember when I worked just as I left school, I worked at a shop called Unilet Products, and they, a chap who used to build these up used to put these Valhalla boards in, and this is basically this was an electronic upgrade that allowed you to have, it's got a quartz crystal lock, and it's got a couple of dividers, and then it just runs through these filtering capacitors out to the motor. And it's got a little LED switch here. Now it's only 33 RPM these. There's no provision for 45. You can actually put a larger pulley on top of the existing pulley of the motor, which will gear you up to 45 RPM. And there's a Hercules 2 board upgrade that you can do to take them to 45, which allows you with the electronic switch to select 45. Which, when I bought the turntable, I did consider, but the amount of use it gets, to be honest with you, I probably won't bother. So this is basically going to turn into like more or less a full service on this LP12. This is the Tonearm, the Akito Tonearm. Now, the other thing I did notice a couple of years ago is the bearing became, well, it felt like it had a bit of a tight spot, and it's not unheard of on these Tonearms. I think I bought this Tonearm for 150 quid on eBay. Now the bearings are inside here, and they're prone to getting dirt and craps inside them. So basically what I've done is I've given out a squirt with WD-40, cleaned out, and dropped some high quality watchmaking oil in there. And I've come back this morning and it seems to be totally free. It doesn't seem to have that tight spot anymore. Now, I know a lot of Linn aficionados out there will say, oh God, take it back to Linn, they know what they're doing. Yeah, take it back to Linn. This is a £150 Tonearm, okay? They want £150 to service it. I'm not spending £150 on something that basically I don't use that much. And I'm not paying £150 for someone to take it apart, clean the bearings, and put it back together again. That's a bloody rip-off. Linn have always been a bit of a rip-off on their servicing, as a lot of companies do as well, I must admit. So, yeah, the plan is, with this board, let me take you out to, it's got some better light. This board, find somewhere where the light's a bit better. We've got, excuse the dishwasher, that's not my stomach. We've got 3 electrolytic capacitors here that are prone to drying up, and I'm not really surprised because they're next to these power resistors, and these power resistors run really hot, and you can see by the gunge on the board. I'll get you some decent light. You can see how hot they've got, they've all gone dark around the edges. So everything runs really hot here. And these capacitors, these Philips capacitors, I've got some replacements for those, for 400 volt ones. What I'd like to try and do is reposition some of these components away from their hot counterparts, particularly those bloody power resistors. I don't like those. That's a 15K, probably wire wound. I might try and mount that on the back of the board, because the board sits like that underneath the turntable, so therefore the resistors will be, heat will be convecting up. So I think that's probably what I'll do, is I'll swap those around the other way. Yeah, I mean, that's basically what I'm going to start with. I'm going to start with changing these 3 electrolytics. There's a couple of other electrolytics here that probably need replacing now. These polyesters, they're fine, never need changing, not worried about those. We've got a couple of trim pots here. This trim pot sets an 85 volt potential across the motor, and that's basically torque to the motor. I think it's more as like a field winding, I think. There's another pot down here I see that's been added at a later stage, and you can see that. I'm not sure what that's doing. Might have a look into that. That might be a speed adjustment, but I doubt it. You see, it's across. Looks like it's across those two. Looks like maybe Zenas or rectifiers down there. So the first thing will be is to get this board a bit cleaned up, get the capacitors changed, and then I think. But first of all, before I do any of that, I'm going to get the motor out, and then we'll have an investigation of that. Okay, I've cleaned the motor up. The top part here, this bearing in here, it's got like a little like a moat sort of thing around it that almost looks like it's designed to hold in oil, and that was just full of crud, black filthy muck came out. I just washed that out with WD-40, got all the muck out of it, and likewise on the underside. Obviously that's not going to hold in oil, but there was a sort of like a grease in there, or an oil that had gone all hard and crusty, like they do on the turntables. So cleaned all that up. Runs lovely now, nice and smooth, much freer. This is the oil I used. It's just a watchmaker's oil. Super fine watch oil, basically. So that should be fine for that. Now the other thing is, excuse me. This is the central spindle of the turntable. I think Linn recommend using a graphite oil on this, but I'm going to use just a fully synthetic engine oil, which I'm sure is fine. You take you over to the centre spindle. This is the centre spindle here. Now I've got this plugged at the moment because I want to see all the black that's come out of there, and that's pretty because it is graphite oil indeed. So I might be able to get some graphite oil. I've probably got some at work. I'm not sure why they use graphite oil. I'm not sure if it's to keep. I sort of in the back of my mind, it's to keep the turntable properly or better grounded, the actual platter grounded to the chassis. But I'm not entirely sure that's true. That might have just been something I've imagined at some point. So, okay, the motor's ready to go. So really, all we're doing now is waiting on the board to be recapped. So what I'll do is when I take this board down the workshop this evening, I'll get these caps out and see if we can think of a better way of mounting those resistors, maybe get them away from the electrolytics, or even mount the capacitors on the other side of the board. But I just want to get the heat away from those electrolytics. It's not going to do them any favours in the long term. And hopefully if I can replace these capacitors with 400 volt capacitors, if they'll fit. I'm starting to look at it now. Actually, it looks like we've got an extra space. You see between these two capacitors there's a extra hole for longer legs, so I might be able to mount them there. So you clearly had some work done at some point. There's a bit of a ratty joint there, but we'll go through and check it all over, give it a clean up, and hopefully get some idea of what that other variable resistor is doing as well. I'd like to know what that's doing. One other part I would like to just have a look at is the power switch on these are a bit prone to switch bounce, by which I mean when you press the switch sometimes you get a multiple activation and you'll see it come on briefly and then turn itself off, and that's basically because what's happened is when you press the power switch it's turned it on. When you released it, it's gone off and turned it back on again. So it's basically sort of like toggling itself on and off because there's a bad connection. Usually a dirty switch will do that. Quite a few things prone to doing that in the past. I've known calculators to do the same thing. When you press a button down, it will strobe about sort of five digits. Like if you press 8 down, it will strobe up about 3 or 4 8s for one hit, but caused by bad contacts on the switch. I have cleaned the contacts on this switch, and it seems to be okay at the moment. But one thing we could do is actually try and actually put a bit of filtering in here to try and stop this from happening. So you see, this is our plug board, and we're connected across 5 and 4 on the switch. We come back to here, 5 and 4, and that's these 2 points here. Now what I was thinking of doing is, that looks like the input to this for the trigger, the 9 volts. You see this 9 volts comes across here and then feeds into this little regulator or whatever it is. Now it looks like it goes high low, so you give us a positive signal to this point here. Where are we? You can never see when I'm pointing at when I'm on the camera. So on this, it triggers this pin 9 of this chip high, and then triggers it high again, and it sort of toggles high-low, so it's like a flip-flop circuit. So if I put a bit of capacitance, see where I've drawn that capacitor in, a bit of capacitance across there, maybe 1 microfarad, something like that, that would hopefully filter out any sort of multiple operations, rapid multiple operations. It might mean I need to push the switch down for half a second or so. That's fine by me, you know, I'd rather that anyway. Just a delayed start, so you push the button down and it starts, push the button down and it stops, you know, so it's not instantaneous, because now if you just press it on and off rapidly, it just switches on and off rapidly. So a bit of filtering there I think would help a lot and improve things. As for that resistor, I've just been having a look on the circuit, and it looks like it's been stuck. I don't know if it's been stuck there because someone didn't have the right value, but it's been stuck between these points here. These are the 2 Zenas here. We've got 68 volt Zener that side, and the top one, yeah, 2 68 volt Zenas in series. Oh no, back to back, aren't they? Okay, so I need to work out what that's actually doing. It looks like a sort of like a voltage limiting sort of thing, just a crude voltage regulator. So yeah, we need to that 12k resistors. I don't know why they put a pot in there. Maybe just because the diodes don't conduct properly and they just a bit more current through them. Maybe. I might have a look on the internet to see if anyone else has done anything like this before. But I'm trying to find a version of this unit. Well, it just says Linn Products Limited and Sondek on it. Danger high voltage, because clearly this is, you know, this is taking 3-phase mains, single-phase mains, and sort of, you know, there's no isolation transformer or anything. So all of this is a mains potential. Pretty dangerous board, really. Not sure you get away with that nowadays. You probably have to put an isolation transformer in. Yeah, and also, as I was saying, I think there's room to mount those resistors on the other side of the board. That gets them away, gives the capacitors a bit of a better time. And also, I think I noticed here, let's see this, one of these I noticed that looked like it had a dry joint. Is it that one? Can't really tell. It's all handheld, I'm afraid. One of these capacitors here looked like the joint was pretty dry. Can't see it now, it's not going to focus. But anyway, let's get this thing apart and get the new capacitors in. Oh, before I say too much, look at that. Bloody hell, just noticed that. Bridge rectifier. Can you see that bridge rectifier? Bloody great split down it. So that bridge rectifier looks like it's been toasted. Oh look, cap's come off it. Interesting. Good God. Okay, so that's the outer case of the bridge rectifier. I've never seen that before. It looks like the rectifier itself is actually inside it and is absolutely fine, but it's like an outer case has come off. Well, I'll check it. I mean, it was working, so I don't think there's a problem, but obviously the plastic case has just disintegrated like an external cover. That's interesting. Never seen that before. Okay, anyway, we'll give this board a bit of a clean up. Obviously needs a bit of TLC, and we'll go from there.